So last week we were looking at the Analytical RTA module, and we actually used the default time function, which is material balance time. The reason why we use material balance time is that we're using the so-called constant rate solution of these analytical equations to then derive A root K and also potentially resolve parameters such as permeability and fracture half length, etc. Hence, we need to convert all our data into a constant rate solution space, which is the material balance time. However, we have an alternative time function here, which is just using real-time data. What that means is that we're just using, call it the variable pressure, variable rate as is, when we create the square root of time plot and pressure normalized rate plot, etc. But in this particular time function, we're doing exactly the same type of analysis. The first thing we need to do is to pick a straight line on this spot. I kind of like this this pick actually, so I'll just move my time to linear flow here. What I see here is that time to linear flow looks very suspiciously close to the saturation pressure. So when the well drops below the saturation pressure. So that might indicate that some of these effects are multi-phase flow effects and not actual boundary effects. I might want to go in and do the analysis again also in numerical RTA to make sure that this time to end of linear flow is actually the true time to end of linear flow. And then yet again, my job after picking this time to end of linear flow and this particular slope right here is then to provide some empirical assumptions for the rest of the data. And using here a rate exponent of 1 seems to be doing an okay job. Maybe I can be a little bit more generous. That was probably a little bit too much. 1.1 maybe, and we can say, yeah, that's probably, let's say we're happy with a rate exponent of 1. And yet again, the same things apply, that if I change any of these parameters in this window right here, double my number of fractures, etc., we're just solving these parameters for permeability and fracture half